This video is for Math 120, Section 1.4. It's basically an exercise in understanding how best to get the good screen out of your calculator. So I'm going to start with this, and it suggests that we're going to put y equals sine of 50x. So I'm going to go into y equals and put sine of 50x. Now it suggests a viewing rectangle, which is negative 12 by 12, so that means negative 12 to 12, which means in the window I'm going to put my x's as negative 12 to 12, enter 12. I'm going to leave the x scale as 1 because that tells you how many tick marks there are. It doesn't say to change that, so I'm not going to. So every unit there's a tick mark, and then it says negative 1.5 to 1.5. So I want to use the negative on the calculator, 1.5, enter to 1.5. This is the Wabbit emulator, but you have similar things available for Mac, so if you don't have a calculator available on your desk, you'll need to get this one in order to do your work. So now I want to graph it, and I've changed the window, so don't do any zooming here. It'll change the window back to some other zoom feature. So let's just do a graph, and we'll see what the graph looks like. So you can see my graph kind of looks like this one here. You've got some weird stuff going on, but it's hard to see on the graphing calculator because this is what it says it's supposed to look like. Change the view of my triangles, maybe see, then we end up with things that look like this. And mine showed a little better than this. So if I change my viewing window to negative 6 to 6, like this, so go to window and change it, and then hit graph, I should see a little better graph. But you see I'm still not getting the windows that they're showing here. So the graphing function that I'm seeing kind of looks a little bit more like that. So in order to explain the big difference between these, we want to say what the differences are. So here they're not asking for anything big. So it says that if we have the function y equals sine of x has a period, whatever, and the graph of y equals sine x is compressed horizontally by a factor. So what is the period of the sine function? If you don't remember that it's 2 pi. So you put in 2 pi. And this is compressed by a factor of 1 over 50 or by a factor of 50, and I'm not sure which one they're wanting there. So then they're saying that you'd have to divide by the 50 here. So that would be pi divided by 25, and you end up with approximately. So this tells me that I should put in very small values into my window in order to see what those values are. So this is like negative 0.25. Y equals window negative 0.25 to 0.25. If we graph that, we get the nice graph that we see here. So this is just about how are we going to interpret what we're seeing on the calculator, because you can see the calculator does not have enough pixels to show us the fine qualities of a graph, especially if you're working with one that is not colored, a color edition of this calculator. On the next problem, they're trying to see that the 1/40th cosine 40x is going to make just a very small difference. So just think about what they're wanting for these answers here. You remember that this is a vertical shrink for the cosine function here. So it's just going to give a little bit of a wiggle there. They changed their window here to be very small. On question 3, they're asking you to replace the c here, x cubed plus cx, with different numbers. So there's several ways you could do that on the calculator. So if I put it in y equals clear, I'm going to write x cubed plus cx. X to the third plus cx. Now the c is above one of these keys, so let me change the skin here so we can see what where the c is. And the c is above here, so to get that I'd have to do an alpha c. Now if I go back to my main screen and change my c, if I put, it says negative 4, and then the stow button here, STO, see it puts an arrow there, so I'm putting negative 4 into my C box, which is alpha program here, you can see above there. Hit enter. Now if I do graph, or zoom 6 if you needed to because we were on the other screen, zoom 6, I end up with a graph that looks like this, and I see what would happen if I put negative 4 in. And I'll just go down and look for that. I could have just as easily right here put a different number in for C, but putting in the storage slot, the C here, which is a suggestion, allows me to go back to my main screen and change that C without changing it here. and it really doesn't matter which way you do it. I'm going to put a 3 in and see what that does. So the 3c makes it stretched up a little further. So this term is stretching it up a little further. On problem number 4, they're asking us to find a good viewing rectangle for this. Now, usually when I do a new graph, I'll just do zoom 6 to get it in the standard grid to see what it looks like. And it doesn't look like it's very helpful to me. So they suggest 0 to 8 and 0 to 8, -4 to 4 by -4 to 4, where I'm not seeing anything at -4 over here. So I'm not sure I'm interested in -4 at all. So it gives me a clue as to which ones this might be to give me the best window. So play around with that and see if you can figure it out. For the next function, they're asking the same thing, determine appropriate viewing rectangle. So which ones of these would be best? Again, you put this in, do a zoom 6 to see what it looks like, and then figure out which parts of it you're actually wanting to look at. For problem number 6, if I put this in and I just use my regular zoom 6, then I end up with a graph that looks like this. So this looks like the best answer for me right now. But they're giving me some other graphs that look a little bit different. So whenever you see a graph that looks like this and you got some crazy looking stuff in your function, you want to make sure that you get the best graph you can. So if I do a zoom fit, that's down at 10, I think. So zoom 9, zoom 0. Zoom 0 is zoom fit. So I do a zoom fit and I do enter, and it's going to graph this in a new window that's going to fit the graph to give the best shape for the graph that I could possibly get. And that wasn't very helpful either, because it's looking like this. So it could be that this is my best shape. But instead I'm going to use their suggestion and go from, not so much on the y, well I guess I will change the y. I'll use my suggestion, their suggestion, and I'm going to go from 0, because I noticed I didn't have anything from 0 to 10. I'm going to go from 0 to maybe 30 here. So there's a way to do this that makes it real easy. These are going to be 1, 2, 3, 4, 5 apart, 1 apart, so I'm going to keep the 1. And then they suggest some really small numbers like -0.000. And I'm going to put 5 in here because I'm just not sure what the graph's going to look like. And then I'll put -0.0005 again. Now notice it changed it to scientific notation. So what I put in, 0.0005, should have the 5 at the 4th decimal place back. Alright, so if I graph that, don't do any zoom here because it'll change your window. That's what it's for. It changes the window for you. And I got an window range, so I'm going to quit out of there and go back to window. So in here I put something in incorrectly. I got 0 to 30, that's good. Oh, I put a -5 again. So it's real easy to find these, but when it says quit, don't get all distracted and quit. Actually, that's not what it's saying. Quit. Go on with your life. Finish the math. That's not what it's saying. So I'm going to hit a delete here and get rid of the negative and try that again. Sometimes it's more important to know what to do when you've made an error than anything else. So it's still graphing. You can see the graph here. And now I've got this graph coming up that looks amazingly like one of the ones over here. Now, the important part of this exercise isn't getting the number right. It's understanding what you might have to do in order to see a graph on your screen. For this graph, I'm going to have to solve for y in order to graph it on my calculator. But it's going to give me a plus or minus, and I'll show an easy way to do that. So if I solve for y here, that would be the same as, I'm going to divide by 9 last. So it would be the square root, I see I'm going to have to take. The square root of 1 minus 4x squared. And I'm going to come out of the square root, and then I'm going to divide by 3 actually. Because if I divide this out, I end up with divided by 9, and the square root of that is 3. So if I look at the graph of this, I'm going to do zoom 6 again to put it on a standard window. And it doesn't give me very much there, so it gives me a little bit of a hint here that I might want to look between -1 and 1. So in my window, I'm going to set this for -1 to 1, and it doesn't matter what was in there first, and this one also from -1 to 1. Again, don't do a zoom here. You want to make the graph, and it gives me a graph that looks like this. So really I have the explanation of what this should look like already. I don't have to draw the other piece, but the point is to know how to do it if you needed to. So in y equals, instead of putting negative of this, I'm going to put negative of y1. So I'm not going to type the whole thing over again. I want to put the negative of y1 there. So negative, to get the y1, you're either going to do an alpha trace, if you have the more updated version of this, in y1, or you're going to go to vars, y vars, function, and y1. So if you have a TI-83, you may have to do that. So I'll quit out of there. In y equals, I have this. So I want this and the negative of that. So that's a reflection of the one that was above the x-axis. So when I graph this, I get both pieces, and on the color version of this calculator, the CE, the plus C silver edition, you'll end up with the red and the blue showing up. On number 8, they give you a couple of graphs and a viewing window, and they want to know how many in the given rectangle, how many intersection points you can see. That's just where the graph crosses. Now down here, that's kind of a lead-in to what you're going to need to do for number 9. You basically want to know where these two intersect. And there, you could set it equal to 0 and solve where its zeros are. But I wanted to show you how this is done if you're using intersections. So in y equal, I'm going to type x to the 4th minus x. And in y2, I'm going to clear that and I'm going to type just 5. So I want to know where these two graphs intersect in order to see where I can find solutions for this one equation. So this is kind of an application to intersections. So if I graph this, I'll get something that looks a bit like a W because it's an x to the 4th. It starts up, so I should have it somewhat symmetric about the y-axis. It isn't because of the x term in there, but it kind of looks like a W, like an x to the 4th would. I want to find the intersection, so I need second and then trace. And that gives me these options. So you should hit second once and then trace. And my computer hiccuped for a second, so I had to hit it a couple of times. Second, then trace. And you can see intersect is number 5. You can scroll down or just hit number 5. It's going to ask me the first curve. I'll hit enter. It'll ask me the second curve. Notice it's the red one now, the other one. And then it wants a guess. Now, I know one is to the left and one is to the right. So I might put a guess in here of -5 and see if it can find it. And the intersection there is -1.3794. And it says find all solutions of the equation correct to 2 decimal places. So that'd be -1.38. You do the same thing for the other one, maybe putting in 5 so that you can see it. So that's how you do intersections. For number 10, probably what you're going to want to do is in the window, you're going to want to put very large numbers for the x values here. So maybe 10 million. You can also look to see in the table. So if I look in the table, that's second and then table, where graph is here. If I keep scrolling, I can see how big my y's get. As my x gets larger, my y gets larger. Now this was for 2 different ones, and there'll be 2 different ones, and they'll want to know what eventually happens. It makes it faster if you do a second table and do a delta table of a larger number, remembering that you came in here to change this. So if you look at your table before, again, sometime you'll want it set at 1 again for things like finding factors. So here I might put in 10,000 and then do the second table. So it gives me these huge numbers. See the e's on here? This is considerably larger. 10,000 may be too much for this. You might only need 1,000, but there's the hint for that problem. So in y equals, for the problem number 11, you're going to put the absolute value of sine x minus x and then 0.05. So that's what you're looking at here. And you want to know what values this is true for. So you'll find the intersections of these 2 graphs. Just a heads up here, the absolute value can be found in 2 places. You can either go to math, number, and it's the first absolute value there, or you can go to second catalog above 0, and it's the first value there. So second and catalog is above the 0. So either place to find the absolute value. I'll let you work on those on your own. I've already given you a suggestion for what you can do with the c's here as far as storing a number in the box and seeing what you have available there. But you could put this function in several times with the c in there and get your calculator to do it. So you can see what these different graphs would look like. I recommend at least putting in a c of 0 to see where it starts, and then putting in a c of maybe 5, and then a c of maybe -5 to see which one of these graphs match best with what you're looking at. So remember that as c decreases, that's becoming more and more negative, and as c increases, that would be becoming more and more positive, so using larger numbers there. So just be careful when you pick your answer. So from the 1.4 exercises here, you should be able to effectively use your calculator to generate graphs that are a little bit more descriptive of what you're actually seeing with the function.